Hey Huskies, welcome to Domain and Range Part 2. So this one, when we're talking about that third objective, can you choose a realistic domain and range for a function? Okay, so we might talk about a parabola or an exponential function, and we don't always use all the values. There has to be some realistic circumstances. For example, when we talked about our pizza example, it was $5 per pizza per player, and then $7 delivery charge. So we can't have negative values there. We can't have a negative input because there's not a negative player. We also can't have a negative amount of money because we're talking about the cost is $5, right? So negatives don't work for either X or Y, the input or the output. So it's really important to be able to understand that there are some restrictions and can we choose a realistic domain and range. Okay, so let's look at an example. So consider the house painting problem that we did in chapter 1. Remember, it was 250, a gallon covers 250 square feet of paint, right, of a room. N is the amount of paint, and the area was the amount being area covered of the house. Discuss the domain and range. So the number of gallons depends on the size of the house. So N is our range. So our, if I wanted to start with range, I could. So the range, okay, we're dealing with our variable N because that depends, the number of gallons depends on the size of the house. Now let's think about it. Gallons of paint. Can we have a negative amount? No. You can't have, hey, I need negative 5 gallons of paint. Okay, doesn't make sense. Could you have 0 gallons of paint? And the answer to that is yes. You probably could build a house and just leave it all with studs and no drywall or anything. So it's like, here's this house, doesn't need any paint, right? You could have wallpaper over the entire house like it's the 90s or 80s, and you don't need paint for that if the whole house is wallpapered. I probably wouldn't recommend it, and I hope wallpaper does not come back in style because, ouch. So realistic domain, or excuse me, the range would be N is greater than or equal to 0. So that's algebraic form. You could also have it as greater than, so 0 to infinity. Now, does that make sense? No, you're not going to use infinity gallons of paint. You're not going to use 100,000 gallons of paint. At least that I would love to see the size of the house that would be, and we could find that out for 100,000 gallons of paint. So, think of some restrictions. We just don't know how much we're going to use ever. I don't think anybody has written down the most paint ever used in a house, the number of gallons. So infinity there would be a little asterisk for me, right? So the domain, what is possible for the domain? Okay, the domain, we're talking about the square footage of a house, right? The area of the amount being covered. Okay, so could we have no area covered? I guess the text here is saying that we're not going to have 0 for the amount of square footage because you can't have a 0 square foot house. There's no house. 1 square foot, that you talk about tiny homes, that's a tiny home. So area not equal, I guess the area has to be greater than 0 in this case. So you could have it as 0 to infinity. Could you have an infinity size square foot house? No. I could probably Google largest house, square footage house in the world, and then we could set that limit. Whoops, right there, right? If we could find it, maybe it's 500,000 square foot house, right? You can't have an infinity square foot house. How big is your house? It's infinity. So that's not going to happen. Part B, there's another example. So consider the cricket problem, okay? Crickets, like when I tell you dad jokes and you guys, it's crickets. It's like silent, okay? Consider the cricket problem, chapter 1, where the equation was t equals 1/4 r plus 40, a linear equation. A linear equation has a domain and range that's all real numbers, okay? So what we want to think about here is for our cricket problem, we can't have negative chirps, right? The chirp rate is the independent variable because the crickets are going to chirp no matter what. The temperature depends on the number of chirps, remember. So we're not going to have a negative chirp rate. Could you have 0 chirps? Probably, right? If the crickets are quiet, they get quiet when people are around, right? They don't like to chirp. So we're going to use 0 is, R is between 0, including them, from, you know, and we're going to say R max here. We don't really have a specific number for that. Okay, in this case, I don't know what the maximum chirp rate is going to be. It's going to be thousands. And we could probably have done that up here for, you could said A max, the maximum size of the house. Okay, just a different way to interpret that. So when I told you we can't really have infinity, you probably could have put A max there, right? Because at some point, there's only so big of a house you can build. Okay, the range here, remember, is the temperature value. Now, we can only have a certain temperature in the world, right? We can't have 500 degrees outside. Technically, with this line going up, yes, you could have it. You could have 1,000 degrees. We'd all be dead because the earth would boil, right? So there's got to be some restrictions there. Our lowest temperature we're going is 40, right? If there's no chirp rate, if we plug in 0 in for R, the minimum is 40 chirps, not 0 degrees, right? Look at the equation. If there's no chirps, 40 is our low temperature. So that's our minimum. Okay, so our temperature is a minimum, and I think it was in Fahrenheit, I think. Do we know the max temperature? No, we don't, but we're going to put it, we're going to cap it. There's a temperature max there. There has to be a maximum, okay? Because we would boil and die at some point, okay? Hot, maybe 115, 120, it'd be like the max I'd want, right? So let's do one more here, and I'm talking a lot. Long video. A sunflower. I love sunflowers. You remember the meme? It's like, bro, they look at each other, and if they can't see the sunlight, they turn toward each other. There's a great meme. Look up sunflower memes. They're cute. Okay. So we have this beautiful graph. A sunflower plant is measured every day for height. The height, h of t, centimeters of the plant can be modeled by using a logistics function, logarithmic. H of t is equal to 250 over 1 plus 24 times 9 tenths to the t. Find the domain and range. Okay. In this case, t is going to be greater than or equal to 0. Okay, they already told us that. So every day for t is greater than or equal to 0. Okay, so the domain so far is going to be, that's what we have so far. T has to be greater than or equal to 0. But then we're going to go to we're going to call this big T here. And the reason we're doing that is because the max, we're going to call T the max life of a sunflower. They don't live forever. They die. Everything, unfortunately, dies, right? It's got a maximum life. Okay, and so we have to be very careful of that. So there's that restriction. We're saying T there. You could probably say T max, right, for max life of the sunflower. So at some point that life is going to end, and you could probably Google that with the maximum life of a sunflower, and that could be replaced with T. There's got to be an average lifespan, and that could be where big T is. But we're just saying, hey, big T, it's the max life. Okay, the range of our function, and I got to move my picture here in a minute, okay, for you. If you plugged in 0 for t, you would get 250 over 25, which is 10. Okay, so our range is going to be h of t. It has to be greater than or equal to 10, and if you look at the graph right about there is 10, right? They show us if you plug 0 in, that's the start. The plant starts 10 centimeters tall, the height, okay, and it's going to grow. And notice how what I love about this is that it's going to grow, and then eventually you're going to get to your maximum height. You don't grow forever, right? I maxed out about 6'3.5". Wish I was 6'6", but I maxed out. So this is going to max out, and if you look up there, it's going to be about 250 centimeters is the maximum. So that is the range of our function. So if you have any questions or comments, please feel free to type them below, and we'll see you next time.